Okay, so in this video we're going to solve the trig equation that's on the screen, and we're going to make sure we limit the answers that we find to be in this range. And so we're going to treat this equation like a quadratic. It's in the same form as if we just had a quadratic that looked like this. And if we had a quadratic that looked like this one, we would use the quadratic formula, or maybe completing the square. Quadratic formula is probably more popular amongst students. Just remember that when we solve, we're solving for the cosine of x and not just x. So really, this is just to give us an idea of how we solve. This isn't really part of our work because we're going to use the quadratic formula to find cosine, where a is 1, b is 6, and c is 4. And so if we plug in to our quadratic formula, see, we'd have the square root of b squared, which is 36, minus 4ac all over 2a. And we could simplify this a little bit. Let's see, we get negative 6 plus or minus root 20 all over 2. And at this point, I think it's going to help us to have, since we know, when we look right here, we know that we're probably not going to be able to think of some angles whose cosine gives us that number. We're probably going to need the calculator to help us. So at this point, I'm going to take those two answers. I'm going to go to my calculator and just round. I would round to at least 4 decimal places. And when I punch those in, I get approximately negative 0.7639 and negative 5.2361. So where I'm at now is I've got two equations. Cosine of x can equal this first number, or cosine of x can equal this second number that we found. Now we know that this one over here doesn't make any sense. Anytime we find the cosine of an angle, it's got to come out to be somewhere between negative 1 and 1, or could be negative 1 or 1, but negative 5 falls well outside of that range. So we know there's no solution to this one, so we don't have to worry about that. However, over here, on this side, we can certainly use an inverse cosine function on a calculator to help us find x. So the way I handle this is I usually, for the moment, I just ignore the negative just to make sure I get everything right in my calculator. And if I do that, then what I'm finding is the reference angle. So I indicate that with a hat on my variable. And so I'm going to find the reference angle by taking the inverse cosine of both sides. And of course I'm going to need to use the calculator to do that. So I've already rounded, right? I already rounded my 0.7639, so I'm already going to experience a little bit of round off error. Let's make sure I'm in radians. Okay, so inverse cosine 0.7639. And I'm going to round this to about 4 decimal places, right? So 0.7015. So I've got some round off error, right? So if my answers are maybe a little bit different than somebody else's who worked this problem, it's probably because I rounded a little bit differently. Of course, the more decimal places you keep, the more accurate your answer would be. But we'll go with 4 decimal places. Right, so what I've got here is the reference angle. But remember, back up here was the equation I'm trying to solve. So I need to figure out angles whose cosine is negative. And we know that the cosine would be negative in quadrant 2, where this is the reference angle that I just found. Also in quadrant 3, where this is the reference angle that I just found. So the two angles that I want would be, since this angle here is pi, I'm after this angle, which would be pi minus the reference angle. And I'm also after this angle, which would be pi plus the reference angle. And if I do those, let's just see. Right, again, I'm going to have to round these, so I've rounded several times, but pi minus 0.7015 is about 2.44. And if I punch the other one in to the calculator, I think I get about 3.8431. And of course, if you needed to, you could convert those to degrees, but that should get us our two answers that are in this specified range.